Okay, so as we finish up the semester, we're going to talk about two different types of sequences. In 9.2, we'll talk about one, and in the other in 9.3. Okay, so let's say we have a sequence like 0, 5, 10, 15, 20, and it goes on like that. So you probably could say, I think I know what the next term is going to be. I think I know what the next term after that's going to be. Let's say we have something like 12, a different sequence, 12, oh, shoot, yeah, okay, 5, -2, -9, and maybe you can see a pattern there and know which terms are next. Okay, these are both examples of what we call an arithmetic sequence. So in this first sequence, can you see that you're adding 5 each time? So the difference here is 5, the difference here is 5, the difference here is 5, okay? So if you wanted to get the next term, you'd go 25 and then 30 and then, you know, as many as you wanted to go. Because they have this same difference between each of the terms, it's called a common difference. So on this one, and we refer to it as D for difference, the common difference would be 5, okay? Here, in the other sequence, it's a little bit different, but can you see that you're subtracting 7? You're subtracting 7, you're subtracting 7, but we don't think of it that way. We think of just the common difference as -7. So the next number would be like -16 and then -23, and in this case, D would be -7. So sometimes the difference is positive and sometimes the difference is negative. Just depends on which way your arithmetic sequence is going. So this is a specific type of sequence. It's called an arithmetic sequence, and it has a common difference. The only other thing I want to say on this is when we write them, we think about the first term. Okay, so you have to have some place where you start. Like here, notice I started with 12. I didn't necessarily start with something that's divisible by -7. I could just start any number, 90 or 105 or whatever number I want to start with. But then I'm adding for the next term, I'm taking the first number and adding D. For the next number, now you might be thinking, oh, you take the second term and add D, but we don't really want it to be a recursive formula. So we're going to say we add the first number plus 2D. So you can see how here you added 5, and now from 0 to 10 you added 2 5s, right? And then from here it would be 3 5s, and so on and so forth. So it's a sub 1 plus how many D's you need to get to the term you're getting to. Okay, so I wanted to point out that notation for you. Okay, and it'll make more sense as we go along.